Today we're going to start talking about systems of equations. There are many ways to solve these sorts of problems, but today we're going to focus on how to solve them by graphing. Before we start, let's go over some vocabulary. First of all, a system of equations are two equations, and we will look and see how they are graphed together. So we'll look at basically two different lines. And the solution is where these two lines meet. And where the two lines meet, that's going to be our solution. So it's where the two equations share a common solution. There are three different possible types of solutions that we may see. So first of all, here we see that we have two lines and they meet and form an intersection. And this intersection right here is our solution. And that's going to be written as a point or an ordered pair with x and y coordinates. So that will be one unique solution. Next, you will see in this middle graph here we have two parallel lines. Parallel lines mean that they never touch, meaning they never intersect at all, ever, which means there is no solution to be had here because there's no intersection. Lastly, over here on the far right, we have an infinite number of solutions. And that happens anytime that you have the exact same line graphed twice. So it's where the one line is overlapping another line, and so every single point lines up, so every single point is the same, meaning that there is an infinite number of solutions. So once again, there's three different possible types of graphs that we may see. We may see two lines that intersect, forming one unique solution like we have over here. Two parallel lines, which means they never touch, there will be no solution, or we could have the same line graphed twice, so they have an infinite number of solutions. Alright, let's do some examples together. Alright, here we are given two equations of two different lines, and we're going to find the solution to this system by graphing these two lines. The first line I'll graph in red. Y equals negative 2x minus 4. We'll start with the y-intercept right here at negative 4 on the y-axis. The slope here is negative 2, so I'll go down 2 and over 1, down 2 and over 1. I'm going to go up and over as well to just make sure we follow the same pattern. Alright, now that I have a few points, I'll graph this line by connecting the dots. There we are. Our next line I'll graph in blue. 3x plus 6, go up to positive 6, and the slope is 3, so I'll go up 3 and over 1, then I go down 3 and over 1 and keep this same pattern alive. And I'll graph this line as well by connecting all those dots with a straight line. Alright, we can clearly see the intersection point here, right there along the x-axis. So we have one unique solution here since the lines intersect, and that solution will be negative 2, 0. That's the ordered pair right there where I've drawn the green arrow pointing to that point right there. Here we have two equations again, and we're going to find the solution to the system by graphing these lines. I'll graph the first one in red again. Y equals x minus 4. We'll start with the y-intercept at negative 4. The slope here is 1, so from here I'll count up 1 and over 1. Rise over run, up 1 and over 1. Continue that pattern and go down as well. All we have to do from here is connect all these points with a straight line. Alright, the next line I will graph in blue. Y equals 2x minus 6. I'll start on the y-axis at negative 6. That's our y-intercept. And the slope is 2, or 2 over 1. So I'll go up 2 and over 1, up 2 and over 1, up 2 and over 1. And I'll connect those points with a straight line. Alright, there we have it. We can see here that these lines intersect again. So we have one unique solution right here. And that ordered pair is 2, -2. 2, -2 is our solution there. All right, let's look at another. Here we have two more linear equations. We're going to find the solution to this system by graphing these lines. But this time, notice that these are not in slope-intercept form. So the first thing we're going to need to do is solve for y. We'll need to do this one at a time. So the first one, 2x minus 4y is equal to 8. We'll start off by subtracting 2x on both sides. That leaves us with -4y is equal to -2x plus 8. We'll need to divide by -4 on both sides. That leaves us with y is equal to -2 divided by -4 is positive 1/2 x, and then 8 divided by -4 is -2. The next one I'll do in blue. We have 4x minus 8y is equal to -8. I'll start off by subtracting 4x on both sides, leaving us with -8y is equal to -4x minus 8, divided by -8 on both sides, leaving us with y is equal to -4 divided by -8 is positive 1/2 x, and then -8 divided by -8 is positive 1. Alright, let's graph both of these. So the red one back up here, we'll graph it first. Y is equal to -1/2 x minus 2. So we'll start on the y-axis at -2, since that's our y-intercept. The slope is 1/2, so I'll go up 1 and over 2, up 1 and over 2, up 1 and over 2. And we'll connect these points with a straight line. There we are. Next, for the equation that's in blue down there, y is equal to 1/2 x plus 1. The y-intercept is positive 1. We'll start there. And then from there, we'll look at the slope, which is 1/2. So we'll go up 1 and over 2, up 1 and over 2. All right, we've got plenty of points there. We'll go ahead and graph those with a straight line as well. Alright, now you may have noticed this before we graphed it, but you can see here that these lines have the same slope. So they are indeed parallel, which means they are never going to touch, which means that we do not have a solution here. So we can simply say that there is no solution. Once again, there's no solution because there's no intersection point at all between these two lines, because they're parallel and never touch.